Very good. All right, ladies and gentlemen, thank you very much for taking the time to come out and see us today. My name is Mark Malente. I am an inspector with Basement Waterproofing Specialist. We're a third generation family-owned and operated company based out of Collegeville, Pennsylvania here. So, move right on here. Unfortunately, my laptop's not working, so we're going to go to Plan B, so excuse the un-high-tech display here. Okay. So I'll be talking about a few things today. As I was saying, we are a third-generation family-owned and operated company. We're local. We specialize in waterproofing, mold, and structural repair. And our own main office is a 160-year-old farmhouse based in Collegeville, which has a stacked stone foundation. We actually do waterproofing work on parts of the Secret Service building and Dover Air Force Base as well. This thing's really supposed to be sliding by itself, but I'm going to have to thumb through here. So, okay, I'm going to get out of this and I'm going to start the presentation. Okay, foundations. All right, well, basically all of our homes are built on a foundation. There's many different types of foundation. How the foundation originates is they usually start with what's called a footing. The footing is a poured concrete pad that usually has in it what's called rebar steel rods to reinforce that pad. So that's usually the step one process after they excavate for the footings. So the footings are complete. So now what they're going to do is they're going to erect your foundation walls, whether they're building a home with a crawl space or a full basement. So what they're doing here is they're using cinder blocks. And there's also a type of foundation called poured concrete, where they're actually going to utilize these steel forms and pour the concrete into there. Okay, once again, here's the anatomy of a basic foundation. You have your rebar reinforced footing, you have your foundation wall, then they're going to come in with the basement floor, which is not structural to the home. And underneath of that floor is going to be a stone aggregate, usually a crushed stone. Okay, that right there is a poured concrete foundation. Now, like our own main office over in Collegeville, we have a type of foundation that is stacked stone, which is very common around this area, the Valley Forge area here. So it's basically, it's built like a farmhouse or a castle. Now, a lot of time, these older homes with the stone, they actually don't sit on a footing. So they just started stacking the stones in the ground and just build it right up. A lot of times they're 2 foot thick. Some real old stone homes, they actually start wider at the base and they narrow towards the top. And then inside they actually have maybe a mud mortar mix, or there was even horsehair sometimes inside the border of the stones. And of course, back of this time frame, they didn't have any kind of drain tile system or water management systems in place. So these really did deteriorate over time. Okay. Every once in a while in the field, we will come across an actual brick foundation. So brick is one of the softest of building materials, and they don't fare too well over many years if there's a water management problem. Okay, the newest technology today is a type of foundation called superior walls, where what they actually do is they precast it into a factory, precast poured concrete, and they bring it in a truck, and they drop the walls. It's basically like Legos, and it's on a crushed stone aggregate base, and they can actually have that foundation up in a weekend. So that's a very speedy, economical way of building today. Now I'd just like to talk about water problems. Okay. So in the water management career, we use the term hydrostatic pressure basically every day. So the basic definition of hydrostatic pressure, if you're familiar with it, is water that really doesn't have a path away. So after they build our homes, see what we have around this area is what's called a mid-Atlantic clay. So we have this really dense soil that water just can't perk away very easily. And they build your foundation walls, we just went through foundations, and that soil that's right on the outside of your foundation wall is called backfill. So it's loose and limby like a garden. So what happens is the water will soak in. I mean, just 2 gallons of water weighs 16 pounds. So this water will soak in and water goes to the lowest point. So it'll go down around where the footing is, and then it cannot self-level because the wall is there, so it will build up alongside your foundation wall and create tremendous weight and lateral pressure. And our foundation walls are structurally sound straight up and down, not side to side. So at that point, the hydrostatic pressure that builds up will start to move and damage the wall. Okay, here's a representation of different avenues that the water can get into our older homes. And of course, a cinder block is hollow inside, so a cinder block can actually hold approximately 2 gallons of water, that's 16 pounds. So in new construction, what they do is they usually put a tar on the outside of the cinder blocks, but that tar doesn't last forever underground, so it will actually work its way through the block. Or you could have roots that actually press against the wall and put cracks in there. A lot of times the builders will put an external footing drain system on the outside, external French drain system. But a lot of time, when the water soaks through the backfilled soil, it pulls with its sediment. That fine sediment will compromise that drain on the outside over time. Also, water going to the lowest point creates like a head pressure. So when you have water on the other side of the wall, that pushes down on the water table that's underneath your floor, and that's going to drive it and create cracks. And it's also going to come up what they call the cove area, where the floor and the wall meet. Okay, so we have represented 2 types of foundations here, poured concrete and cinder block. Now, the poured concrete foundations are usually about 8 inches thick concrete all the way through. So when they crack, they usually crack all the way through to the other side, and it creates an opening for water to gain entry into the home under hydrostatic pressure. And this is what, once again, when we talked about the cove area, because there's a seam where they poured the floor after the foundation was built. Now, one of the things that we look for when we go out to our customers' home to perform our free inspections is we look for a dampness problem. Now, a lot of my customers tell me, you know, Mark, I don't have a water problem. I just have this darn white stuff all over my walls. Well, if you folks are familiar with acid rain, the acid in the water and also the soil. When acid looks for a base or an alkaline to neutralize it, that's the lime, the binding agent of cement. So when I see this right here, a lot of times I see the white spotting all over the walls, and a lot of people are under the impression that it's mold, and it's not mold. I'm not saying that there might not be mold on that wall, but what I'm saying is that is the lime being pushed out of the wall. So right there is a textbook example of hydrostatic pressure, because the best analogy to hydrostatic pressure is if you've ever been in a swimming pool and you push a ball down in the water, the pressure that squeezes that ball and pops it back up at you, that's what's happening to our foundations when you don't have a healthy water management system in place. Okay, once again, a leaking cinder block wall. Remember, cinder blocks are hollow inside. They can hold approximately 2 gallons of water.